Hello everyone. In this recording, we try to use the greedy algorithm for the second exercise. This exercise is actually the second exercise among the exercises that you have in your slides. And the name is corridor guard placement. So the problem is that we have a museum corridor which is represented by the interval from 0 to 1, both of them included, and each guard monitors a specific sub-interval of the corridor. The goal is to select a subset of guards so that the entire corridor is covered while minimizing the number of selected guards. A point of the corridor is considered covered if at least one selected guard monitors it. So here are the guards. We have 10 guards, and here is the coverage intervals. So for example, guard number 1 is from 0 till 5, both of them included. Guard 2 from 0.9 till 0.2 to 0.9, and let's say guard number 10 from 24 to 30. So the point is that to choose the minimum number of guards so we can cover from 0 to 30, which is the total length of the corridor. So since we don't have a pseudocode for this one, first I try to write a pseudocode for this problem and then convert that pseudocode to Python code. So let's go to a Word document I'm going to use here to write the pseudocode. So because this is a Word document, it's not going to be as pleasant at the end as what you had in the slides, but I'll do my best to make it, understandable and neat and tidy. So the same as what you see in the lecture, we need to have the input. So let's say we have the inputs, and the input is the capital E, the set of the ground set, which is all the guards, and then we can define another list or another set. I'm just going to call it S sub I. So let me have this one. So we have small s sub I, which is the set of a start point for each guard, and we have another set which we call it the E sub I, which is the end point of each guard. So the capital E is from 1 to 10. Si has the starting point of each interval, so it's going to be 0 to 5 till 24 for each guard, and the same thing we have for E sub I for 9, 11, 14 till 30, which is the endpoint of the last guard. So going back to this one, so we have this one, and then we need to have, let's say, the output of the problem, which is set S, the solution set, and also the f of s, the objective function of that one. So let me also do this one, the thing, and also do this for this one too. Let me do this. So here are the input and the output of the problem for the pseudocode. And then we have can start from different lines. So let's say we have line 1, and so we need to have the initial value for the solution. So the initial solution is an empty set. So we set it equal to an empty set. So this is the initial solution. We haven't selected any guards yet. So this is the one, and then we have, let me do this, maybe it's better here. And 2, and at line 2, we have also the f of s, the value of the objective function, which is which is also equal to 0 at the beginning. Then at line 3, I'm going to define a variable. So if we compare with the previous problem, we had, I don't know if, yeah, I don't have it here. So if we compare it, let's say, to this pseudocode, which is for the previous problem, this is for emergency call dispatch. So if you remember that one, so we have this, let's say, the T. So yeah, so we need to, the same as here, that we have this capital T, which was the cumulative waiting time. We need to also define a new variable for our problem. This one, which shows the last point that is covered by a chosen guard. So going back to the Word document, I'm going to define here a new variable, which we can call it the last covered point, which is so the last covered point at the beginning. Sorry, there's the, which is 0 at the beginning, because we are at the beginning of the corridor, so we haven't chose any guard. So at the beginning, the last covered point is actually the beginning of the corridor. So its point is 0, and then we need to define the set of feasible candidates. So which, as always, we have the capital F. So let me copy paste this one here. So instead of capital S, we have the capital F, and this set is equal to all the guards. So we can have all the guards are possible that their, if we go back to the problem definition, that their start point is less than, or in terms of the problem description, is before that last cover point. So which means that we choosing someone, so we are not going to lose any part of the corridor that is not covered by the guards. So which means that if, so this is going to be I, a guard that belongs to the capital E, which is the ground set, where the start point, which is the SI, which the start point is less than or before the last covered, sorry, let me just copy paste this one. Cover should be actually less than or equal to this one. So this is the definition of the feasible set. So we can choose, so the feasible ones are the ones that their starting point is less than or equal to the last cover point. So in this case, we show that all the time that we cover everything. So for example, at the beginning, if we go back to the problem, the only feasible one should be this guard, the guard number 1. So at the beginning, all of the other guards are not feasible, because if we choose any of those guards at the beginning, so we are not going to cover point 0, because guard number 1 is the only guard that can cover point 0, point 1. And then for point 2, we have another option, which is guard number 2. So at the beginning, the feasible set is just guard number 1. So this is our only choice at the beginning of the code. And then we have for the first line, and when we have the set of feasible candidates and we have those things, now we can go to the body of the greedy algorithm and have our while. So we can say while the last cover point is less than 30, which is the end of the corridor. So towards the while this, the last cover point is less than 30, which means we have some spaces to be covered. So which means we need to choose a guard. We need to look for the I star. So let me have this one. So we can define the I star our best option. So the I star should be the guard. We can have this criteria that we are choosing the guard among the possible guards that cover the maximum length, which means that their endpoint is the highest. So among all of the guards that their start point is less than or equal to the last cover point, we choose the one that covers the maximum length. So the I star is going to be, the I star is the arg max of we have the endpoint EI where I belongs to F. From all the points, all the guards that are in the candidate set, we choose the one that has the maximum EI, has the maximum endpoint, which means we choose the guard that covers the maximum among the possible candidates. So this is going to be our selection. So we're choosing that guard, and then when we have this guard, now we can update the solution set. So we can have this one. So the solution set is going to be the union. So we are adding that I star, so the S is going to be the union of the S, what we had so far, and the I max. The I star. So this is going to be the updated feasible set. And then when we update this one, we also need to update the objective function. So the f of s simply is when we choose a guard. So this is going to be what we had so far plus 1, because we choose one guard. So this is going to be this one. So this is how we update the objective function. And when we update the objective function, what we need to do is to update this variable, the last cover point. So the last cover point is equal to the EI of that chosen guard, which means it's going to be the endpoint of I star. So I star is the chosen guard, and then we have this one. So this is going to be the updated last cover point is going to be the endpoint of that chosen guard, and and then when we updated this one, we need to update also the feasible set. So Control C, and here we need to update the feasible set. So this rules still should be satisfied. So we have to make sure that the SI is less than the last cover point. So we are guaranteed that we cover the whole corridor. The only thing is that I should be a member or an element of E excluded S. So we have this one. Shouldn't that I be a member or an element of the solution set? And when we have this one, we can say that this is the end of the end while, and after that we can return the capital S and f of S. So we can have this one, and then we can return the S and this one. So here is the pseudocode that we can have. We can also add another line of code here between the while. So if, for example, at a point, let's say at the here, if we don't have any guard that started at point 0, so which means that the solution, that there's the problem is infeasible, so there is no actual solution. So we can add a few line here, another line here to check the feasibility of the solution. But since I just wanted to follow what you have seen in your lectures, I'm just going to skip that line of code. So here is the pseudocode that we have. Again, we define the input, we define the output, and here we have the body of the pseudocode based on for the greedy algorithm, based on the criteria that we choose the guard that covers the maximum among the possible candidates. So with this, I conclude this recording, and in the next one, we try to convert this pseudocode to Python code. See you next time.